Okay, we're going to take a look at some quadratic models. First, we're going to look at a vertical motion problem. They give us the formula right here. Okay, we're going to use this formula to answer these problems. So number one, it says a model rocket is projected straight upward from the ground level. It is fired with an initial velocity of 192 feet per second. So the first thing we want to do is we want to plug in the information. Okay, so first of all, your initial velocity right here, V subscript 0 represents your initial velocity. So we're going to have it's going at 192 feet per second. Okay, and then our initial, anytime you see that subscript 0, that's going to be our initial. So our initial height was the ground level. So our initial height is 0. It says, how high is the rocket after 10 seconds? So it's pretty easy at this point. We want to know the height after time is t, 10. Okay, so we're plugging in 10 for t. And if we do that, we're going to end up with 320 feet. So the height of the rocket after 10 seconds is 320 feet after doing the calculation. When is the rocket above a height of 432 feet? So in this case, we know that the height, and we're trying to solve for t, when. Okay, so 432 goes in for height. Okay, we want to solve for t, so we want to set the equation equal to 0. And we're solving this for t. So let's take a look at what our calculator shows us. Okay, so plugging in the equation, and we're solving for t. So going to our graph, we see that one solution is 3 seconds. 1, 2, 3. Double checking that in our table. Here we go, 3, 0. So one of the solutions would be time equals 3. Now another way to do this problem would be to plug in the original equation. Okay, and then we want to know when it's going to exceed 432 feet. So we're going to put y equals 432. Okay, now with this problem though, you will need to adjust the window, because if you graph it, it only goes up 10. Okay, and we have one equation that's 432. So I'm going to go ahead and adjust my window max to say 600. I'm going to go ahead and count by 50s. Let's see what we get here. So there's the rocket. So when does it exceed 432 feet? We're going to do an intersection here. Okay, Remember, intersect, you got to get close to it. Enter, enter, enter. So there you go. It exceeds it at 3 seconds. So that's another way of calculating the time. It says, what is the maximum height of the rocket? Well, that's your vertex. So we're going to second calc, maximum. We're going to go to the left of the vertex, to the right of the vertex. So at 6 seconds. See, when you have this 0.99999, that's when you can round. And at 6 seconds, we're at 576 feet. So that's your maximum height. Okay. When will the rocket hit the ground? Well, the ground is down here on the x-axis. So we're going to have to change our window. We're going to have to go down a little bit more. I'm going to go down to -100 and see what that gives us. So I can see the ground here. I want to know when it's going to hit the ground. So I'm going to need to move over my window. So I'm going to go ahead and first of all get rid of this. I'm done with that. Window, so X max, we're going to go over here. I'm going to go over to 50. Okay. Now can we see where it hits the ground? Right here. So second calc, 0. Left bound. So left of it, right of it, enter. So it hits the ground in 12 seconds. And so each problem is going to be a little bit different. You're going to have to think about it. And we'll see you guys tomorrow. Hope you guys are having a good night.